Hello, this is Peter from Educomondo and a warm welcome to our STEAM project number 8, Teacher Edition, called Happy Birthday. This series is for the very beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. Today we are going to use the passive buzzer. This is a more versatile buzzer than the active one that we used in lesson number 7, the buzzing bee. We are going to build a simple circuit and make the passive buzzer produce a melody by using the command tone. We will also teach how notes are related to vibration, expressed in hertz. We will also apply some new expressions like #define and #include. We will explain the existence of libraries within the Arduino. And last but not least, we will learn about arrays. Remember from our previous lesson, there are two kinds of buzzers, active and passive. Let your class repeat what the differences are. The physical differences are: first, the passive buzzer does not have a paper cover on the top. 2. The passive buzzer is not sensitive to its polarization. Both legs are of equal length. And third, the other difference is the color of the bottom, where the legs come out. If it is greenish, it is a passive buzzer. If it is black, it is an active buzzer. Now, what is the functional difference? The passive buzzer is not able to function on its own. It needs a signal from the outside, like from our microcontroller, to produce a sound. Distribute from the starter kit the following components. If you are using a soldering mat like me, put the components into the spaces. The microcontroller and the breadboard, one passive buzzer, 2 jumper cables. As the passive buzzer does not have a polarity, we can freely choose the color. And let us not forget the most important part, the cardboard bird. Let's take our breadboard and mount the passive buzzer. This is very much the same setup as the previous lesson with the active buzzer. Next, we are going to connect the passive buzzer to one of the digital pins. For this exercise, we connect the jumper wire to the digital pin number 8. We connect the other jumper wire to the ground pin of the microcontroller. At this point, ask your students to connect the microcontroller to the USB port of their computers. Let them confirm to you that all LEDs on the microcontroller are blinking. If all of that works, they can launch the Arduino Integrated Development Environment. First of all, we give our file a name, and we do that in the space above the void setup. We call this file Project 8 Happy Birthday. And next we create another command line, variables. The first variable that we will need to declare is the digital pin that will feed the buzzer. In this project, we use digital pin number 8. int buzz pin equals 8 and closing with a semicolon. It is also recommended to declare a delay variable, as this is one of the most commonly used variables. Remember that this value is in thousands of seconds. int dt equals 500, and this will set the delay time to half a second. Remember that we want to create a melody, so we will need notes, like on a piano. Your students may already be familiar with sheet music. This is a way for musicians to know what they have to play, how fast, how long the individual notes are, and so on. On screen you see the simplified sheet music of our project Happy Birthday. Notes are defined by a letter and a number. For instance, C4 is known as middle C. For our microcontroller to create the right tone, we will have to tell what the notes are. We do that by defining the different notes as a sound frequency in hertz. Hertz is the measurement of frequency, referring to the number of cycles per second. The higher the frequency, the higher the tone. The lower the frequency, the lower the tone. The symbol of Hertz is Hz. It is named after Heinrich Rudolf Hertz, a 19th century German physicist who proved the existence of electromagnetic waves. So each note has a very specific vibration. On our piano, for example, the highest note vibrates at 4186 Hz, while the lowest note vibrates at only 27 Hz. Our middle C vibrates at 261.63 Hz. We want to create the Happy Birthday song. So this is how it looks on sheet music and how it sounds on the piano. Now that we know what notes we need, let's create them. This is done via the #define command. The first note is the C4, and we know that this note vibrates at 262 Hz. So #define note underscore C4 262. To speed up our lesson, we will simply copy the other notes. We will use rounded numbers, so no numbers behind the comma. #define note underscore D4 294 all the way to the next C note, #define note underscore C5 523. Now that we have defined the notes that we need, the next step is to create the melody. To do that, we create a special type of integer called an array. An array is a collection of variables. To set up an array, we use the following code. int melody, open and close the square brackets, equals, open the curly brackets, and here we will add the sequence of notes that will produce our song. We just need to read from the sheet music and put the notes in the right order. As you can see, we start with two notes C4, so the first two will be note underscore C4, comma, note underscore C4, and this all the way to the end note, which is an F4. So we end with note underscore F4, close the curly brackets, and end with a semicolon. Next to the pitch of a note, We also have the length of a note. In other words, the duration a note is played. On the sheet music, you notice that some notes are connected, some are solid black, and some are outlined. For our song, it is sufficient to know that the solid notes are quarter notes, the outlined notes are half notes, and the notes with a horizontal line are 1/8 of a note. We call our array note durations and fill it with the values that we read from the sheet music. 8 stands for 1/8 of a note, 4 stands for a quarter of a note, 2 for half of a note, and so on. Just make sure that the total number of entries in both arrays are the same. This is very, very important. In our case, it is 25. int note durations, open and close immediately the square brackets, equals, open the curly brackets, and the first two notes, as you can see, are linked to each other, which means that there are two notes of 1/8 of a second. So 8, 8, and then the whole sequence until we end with the last note. And as you can see, this is an outlined note, so we call it 2 because it's half of a note. We close the curly brackets and end with a semicolon. Make sure that the total number of entries in both arrays are the same. As I said, in our case, this is 25. And of course, we will have the Arduino count this for us by using the sizeOf command. So we create another variable, integer song length equals the size of the array melody. And we end again with a semicolon. Next, we create a variable that refers to a note and its position in the array. Because this variable will be defined in a for loop, we don't attach a value to it as yet. So integer this note. Within the Arduino programming language, there is the command tone. Technically, the tone command generates a square wave at a requested frequency and a 50% duty cycle. Because we don't want to repeat the song forever and ever, but only play it once, we simply put all of the code in the setup space. And of course, we will apply our well-known for command to loop from one variable in the array to the other. So we use for this node equals 0, which is the first position in the array, and for as long as this node is smaller than the song length, which we know is 25, then we just add one more position to this node. And this can be written as this node plus plus. We open the curly brackets, and we know that in this loop, we first have to define the duration of the node. This is calculated by dividing 1 second by the duration of an eighth, a quarter, half, or a whole note. So we use int node duration equals 1000 divided by the node durations of this particular node. Then we use our new command, the tone command, to send the frequency and the duration to our digital pin. Tone, open the brackets, and we send to the buzz pin, first of all, from the array melody, a particular note, so a frequency, and then secondly, we send the note duration. The note duration, which has been defined as 1000 divided by the specific note duration of a note. So divided by 8, 4, 2. Because we don't want the tempo to be too high, we also include a delay between the notes. Now, instead of defining a fixed delay, we make the delay depending on the duration of the note. So we create a new variable, int, pause between notes, equals the note duration multiplied by 1.30. This gives a good pause between the different notes, not to make it too slow and not to make it too fast. So we add the delay, pause between notes, and end with a semicolon. Now we stop the program by sending the command no tone to the digital pin. So no tone, in between brackets buzz pin, and we close the for loop with the curly brackets. Now it is time to upload the code. And we get an error message. So let's have a look what the error message is telling us. It says that the song length has not been declared in this scope. Okay, so let's have a look what's wrong, because we did declare it on line number 30. But what do we see here on line 37? That we have misspelled song length. So let's give it another try. Upload, and yes, now it is working. And your class should be filled with the music of Happy Birthday. This is already quite a complex program, so hopefully it works for all of your students. If it doesn't work, tell them do not panic. Step-by-step diagnostics is one of the most important skills in programming. Let them systematically check. What was the error code in the Arduino IDE? Did you end all commands with a semicolon? Did you type all commands correctly? Did you put the wires in the right pin? Did you declare the right pin number as a variable? Are all connections on the breadboard firm? Is the buzzer not broken? Before we wrap up this lesson, I want to introduce to you libraries within the Arduino. Libraries are pieces of code that other people have already written, so that the programmers can freely use them. One of those libraries is called the tone library, and it contains all the notes and their hertz value. It is one of the most popular libraries in the Arduino IDE. To make use of such a library, you have to call it by typing the #include command at the beginning of your sketch. So #include, and in between pointed brackets, tone.h. This is one of the few Arduino commands that does not require a semicolon to end. With this library installed, you have access to all the nodes, so you don't have to program them yourself. That is great about the Arduino open source community. Many people make your life so much easier. In later lessons, we will start using more and more of these libraries, so stay tuned. Let's review with your class what they have learned. They used the passive buzzer. This is a more versatile buzzer than the active one that we used in lesson number 7, the buzzing bee. They built a simple circuit and made the passive buzzer produce a melody by using the command tone. They now know how notes are related to vibration expressed in hertz. We taught them some new expressions like #define and size of. They are now aware of libraries within the Arduino IDE. And last but not least, they learned the basics about arrays, a special kind of integer that is used very often in programming. Because we experimented with sounds and tones, you can give them a musical assignment. These questions are suggestions. By all means, use your own creativity to design homework for your class. What is your favorite style of music? Can you name 5 styles and explain why they are different? Do you play an instrument? If so, can you bring it for the next lesson and play a melody? Can you program the tunes of your favorite song in the Arduino? What is the frequency range of the human ear? Is that the same for young and old people? What frequency can animals hear? And what does ultrasonic mean? Which animals use ultrasonic sound to navigate? Explain how that works. Have fun with the assignment. I enjoyed this project very much and I'm eager to start with our 9th lesson. In that lesson, we will introduce a new component, the shift register. Shift registers are often used to increase the number of input and output pins on a microcontroller. For example, if your project needs to control more LEDs than there are pins. We will learn all of this in our next project number 9, the laser bar. Bye bye for now.